Okay, so now we'll do a few word problems here. And I went ahead and wrote down the formulas over here that we learned this chapter, or this section. I don't think you need to write them down because you have them on your notes, but just so you can kind of see what I'm referencing here. All right, so our first one here, it says, 2 ships leave a harbor at 1 p.m. One is traveling with a bearing of north 42 degrees east. Okay, what does that mean? Well, if we kind of look at our northeast, southwest, what is it? North, east, south, and then west, like California. The west coast is the best coast. All right, so north 42 degrees east. What that means is you start north and then you move 42 degrees towards the east. So it kind of tells you where to start and then move this much that way. So I would draw it like here, and then the 42 would be right here. So it's 42 degrees east of north. But I like reading it better, like start north and then move 42 degrees east. It's going at a speed of 18 miles per hour. Let's hold that thought for a minute. Let's work on the directions first. So the other traveler is traveling with a bearing of south 15 degrees east. So let's see if you can draw now using that same technique that I just went over. Where would south 15 degrees east be? All right, so I'll go ahead and draw it then. So I would draw it right here because we're starting south and then we're moving 15 degrees east, okay? All right, and then the question here is how far apart are the boats at 3 p.m.? So I'm going to draw a line from here to here. And I'll label this one boat A and boat B here. And we are trying to find the distance in between them. I'm actually going to take out the east line there. And so this is the distance we're looking for right here, okay? All right, so what do I know here? Well, I can know this angle in here, which is going to be very important for me on law of cosines. And I can know that angle because this is a straight line between north and south. And so we know a straight line is 180 degrees. And so we can do 180 minus 42 minus 15. I'll go ahead and do that on my handheld calculator. And so this is 123 degrees. Okay, and then we also need to know the distances of the other two sides, and I think that we can know that, okay? So the other distances are based on the speed and time. So this first boat was going 18 miles per hour, but we went from 1 p.m. to 3 p.m. So how many hours was it going 18 miles per hour at? Well, it was going 18 miles per hour times 2 hours, right? So if it was 30 minutes, I would multiply that by half an hour. So it would be a distance of 9 miles. In this case, it would be 36 miles. So then same, same deal for the other one. The boat B is going 22 miles per hour, also for 2 hours. And so that would be 44. Right there. Okay, so we know a side angle side here. Okay, so that's a good indicator. We can use law of cosines to find the opposite side. Also remember, when we don't have an angle with its opposite side, that's when we use law of cosines, because if we have an angle with its opposite side, we can use law of sines. So I'm going to be using law of cosines, which I wrote over here. So let's go ahead and do that. So in this case, I'm going to say my a is really what I called x there. So I'm going to say x squared equals, and then we're going to square the other two sides and add them together, minus 36 squared, minus 2 times those other sides, times the cosine of the angle, which in this case is 123 degrees, okay? Remember, finding sides with law of cosines is not a lot of solving. You're really just typing it into a calculator, but also remember, we want to type it inside of a square root since that equals x squared. So I'll go ahead and do that. Okay. 36 squared plus 44 squared minus 2 times 36 times 44 times cosine of 123. Since I just opened my Desmos, I'm pretty sure I'm on radian mode, so I'm gonna go ahead and switch this to degree mode. Oh, the answer is not that different actually, but still matters. So on degree mode, this says 70.4 miles. I'll write it here, 70.4 miles. So there we go. Does that answer make sense in the context of the triangle where it's drawn? I'm going to say yes, because 123 would obviously be the biggest angle in that triangle, even though I don't really know the other two. But if it's greater than 90, it's got to be the biggest one. And so 70.4 is the longest side opposite it. Okay. Awesome. Okay. Next question, very similar. So this person, they wanted to find the distance across a lake. They took the measurements below. So this one, I mean, it's really the same setup as the other one, except they drew the picture for us, right? So I'm just going to jump right into my law of cosines here. This one is really easy, barely a word problem. I guess we would call that opposite side like little c. If you wanted to call it x, that's fine. All right, so we'll just type in the square root of, and then those two sides squared and added together, minus 2 times those sides multiplied together, times cosine of 40.3. All right, awesome. .82, 3.56. Okay, there we go. 2.3 sounds like a reasonable answer there. All right, is that a reasonable answer with this triangle? I would actually argue yes. 40 degrees is kind of like usually a middle kind of degree. It could be the smallest degree in a triangle, but it could be a medium one as well. It's probably never going to be the biggest one. So this one, it looks like it is the smallest. So I think that's reasonable. All right, last one here, going to be a tricky one for sure. So businessman wants to buy a triangular lot in a busy downtown location. The lot frontages on 3 adjacent streets that are those feet lengths. What is the area of the lot? Okay, so it does not say that this is a right triangle, so I'm not going to assume it is. So we just have 3 sides here that are 315, 280, and 125 respectively. and they want the area of the lot, okay? So ultimately here we're trying to find area. Usually when you buy land or buy real estate, you're usually kind of somewhat paying by the square foot. So that's what area is square feet. So to find the area of a non-right triangle, we did learn a formula in this section, and that is 1/2 AB sine C. So in order to use that formula, I'm going to need one of these angles in here, okay? Because I have all the sides, but to use that area formula, I need the angle in between two of those sides. Does it matter which angle I find? No, actually not really, because I just need kind of the angle in between two of the sides that I already know, okay? Now, we kind of always said find the biggest angle last, correct? So when I'm finding angles, I'll go ahead and just find the smallest angle here. So I'll label this one theta. And so I'm going to have to use law of cosines to find that angle. And then I'm going to use that in my area formula to find the area, okay? So how are we going to do that? Well, we know if we want to find this angle out here using law of cosines, that means in the front of the formula, we need its opposite side, which will be 125. Then we'll put the other two sides in here. Okay, so now we're using a law of cosines to find an angle, which I told you guys on Tuesday was much more difficult than using it to find a side. My advice was always to do 3 separate calculations as your next step once you set that up. So I'll highlight those calculations again. So 125 squared is 15625. 280 squared plus 315 squared is 177,625. And then this one is negative 176,400 cosine of theta. As a quick reminder, we never want to subtract these two numbers because the second number is attached to cosine theta, so it's a non-like term. So I'm just going to subtract the 177,625 over to this side. 5625 minus 177,625. So I got negative 16200. Oh, 2000. Okay, I'm going to now divide over the negative 176,400. And I have cosine theta equals this fraction. I usually don't worry about dividing this fraction because we're going to put it inside of a cosine inverse in a second. But if I see zeros here, I'll go ahead and cross off those zeros. Remember, we can't do that on the law of sines if it's inside, if these numbers are inside of a sine, but they're not. So that's fine if you want to cancel them out. So then I'm going to say theta equals cosine inverse of, and I have a negative over a negative here, which I told you happens about 80% of the time on these ones. So I'm just going to make that a positive over a positive, and I'm just going to leave that as a fraction. All right, so we'll do cosine inverse of 1620 divided by 1764. So I get that theta equals 23.31 degrees. Now, that's not my answer to this question because I wanted the area, correct? But now that I have that, the two sides with the included angle, I can use my area formula for a non-right triangle. So we learn area equals 1/2 A B sine C. I wouldn't really worry about which one we're calling A, B, and C. The big thing on this formula is that that angle needs to be in between the two sides that we're doing. And so you can see that it is. So 0.5 times 280 times 315 times sine of 23.31 is going to give you my answer to this. So the area of this is 17,450.6 square feet. Square feet is just the unit of measurement for area for feet. Awesome. Okay, so that's it for notes. So now we should work on our 6.6 practice web assign. I think it's